Hello, this is a video for SOEN6441, Advanced Programming Practices. This is for week 5. Here I'm going to talk about the observer pattern and the MVC architecture. So first, before I start, maybe you can see here that there's some code here that comes with this particular lecture. If you take this code and, for example, put it in Eclipse, you're going to have all these files here. These are exactly the same files I'm having in the slides. Okay. This is what the lab instructor has been told to actually show you in the lab. So I'm not going to go and describe in detail what the code is exactly here. Well, I'm going to go in some detail, but not all the details. So if you want to have more details, please go to the lab. Then let's go. So this is for the slides here. That's the slides I'm showing here. So here I'm going to show you what is the model view controller architecture. This is one of the many different kinds of software architectures. Not going to cover many of them, just this one, because it applies very much to the kind of project that we have, which is a game. So, and then there are many other kinds of architectures, but I'm not covering them here. Now, you don't have to use the MVC architecture in your project, though it's advisable because it applies very much. And it's quite clear that given the example I'm going to give you, that it actually applies very well to this kind of project. I combined this with the observer pattern. So as you see in the list of topics that we're going to cover in the future, there's design patterns. So we're going to cover quite a few design patterns in the course for the purpose of actually including them in the project. So the observer pattern is the first one in a series of design patterns I'm going to show in the class. Why am I showing it here? Because actually the observer pattern is a part, it's a component that is part of the model view controller architecture. Now let's start with a little bit of history about the MVC architecture. So this was first introduced by Trygve Rinskog in the Xerox Palo Alto Research Center, 1979. As he was actually working on the Smalltalk programming environment. Smalltalk is one of the first object-oriented programming languages that were, how would I say, it's not the first programming object-oriented programming language. The first one was Simula, which was invented in the late 60s. But Smalltalk was one of the first that were, how would I say, fully functional as using the concepts of object orientation as we know now. It was also very famous for actually being one of those programming languages that was complete enough so that it could actually be used to implement the entire IDE and compiler and all the machinery that was necessary to actually compile the programs and execute them. So Smalltalk was also very famous for being one of the first programming languages for which an IDE was developed. I mean, a graphical user interface IDE, as we actually know it now. So you see that this dates from, well, the IDE is probably dating from the early 80s. But you see that some people think that object-oriented programming is new, that IDEs are new. There's that myth as to whether the things that we're using now are quite recent. If you know your history of computer science, you would know that very few things that we are using now are actually new things. They're somehow ideas that people invented early. They did not necessarily catch on, but only now we figured out how to use it every day. Incidentally, also in Xerox Palo Alto Research Center at this time also, the Smalltalk programming system was meant to be used with one of the first, if not the first, computer that was using a mouse and the notion of an operating system that was actually using Windows. So I guess, again, another myth. Some people think that Microsoft invented the notion of Windows. No, some people think it's Apple who invented it. No, actually Apple, Steve Jobs went to the Xerox Palo Alto Research Center at some point, and he saw this computer that was using a mouse and Windows and so on. I was very impressed. Actually took the idea from there to actually create the Apple computers. So again, a lot of myths about whether what we know. People think that things are new that we use now. Not so in many cases. So this is actually in this context that this person here actually invented the model view controller architecture. It's basically based on the idea that you have this view. The most important distinctive aspect here is the view, which is in this case a window that was shown to the user, and that the user could actually interact with the mouse on the window by clicking, for example, and using menus that were available on the window and clicking on actually the screen. So there was user interaction. So it was one of the first systems that had graphical user interaction. So it has the view, and the controller is there to actually catch the events, for example, clicking and so on, or the user would enter some data in the view and would click, for example, submit on a button, and then the controller would get the information from the view and then would feed it to the core of the system, which is actually the model. The model is the state of the application. So for example, in our game, the map class, that is essentially a graph that represents the different countries on the map. This is just a data structure. It's not a graphical representation of the map. So the controller would actually tell, for example, the map that a certain player is attacking another player, and then a function inside of the model would be called to somehow implement it or simulate this attack and so on. And then the state of the map would change depending on the result. Then eventually, as the state of the model is changed, then the model objects would actually notify the view, which would then update the view of the map. Okay. So you have this loop that is happening here between the model and the view and the controller. Okay. It's also some kind of event-driven system, obviously, because the controller is trapping some events, which are mouse clicks on the view and so on. So this is one of the early examples of event-driven graphical user interaction. This is the general idea of the MVC. Now, here I was explaining using GUI, but I will also, my example that I will give, which is a very simple Java program, is actually not using GUI components. It's basically just getting some input from the keyboard and then actually displaying some information on the application console. So it does not need to be graphical oriented application or graphical user interaction oriented application. So that's the context of what is MVC in a short description. So here are the description of each of the components or each of the subsystems, because the model is actually composed of several classes. For example, in our project, you have the map, and then you have the player, and then you have the territories that are on the map, and you have the cards. These are all parts of the model classes of the entire application. The model, of course, what it does is that it stores the state of the and the behavior. It stores the state of the application and implements the behavior of the components of the business model or the application domain of this application. Okay. So you see that the model, all it does is implement the business model, the application domain. It's absolutely not concerned with user interaction, nor with displaying information. So that's what is the distinction, the distinctive characteristic of this architecture is that it separates the concerns between the business model, the displaying of information, and the mechanics of user interaction. Okay. So the model is there to store the state of the application and to represent as part of, as methods, the behavior of the actual application. So other things that is also responsible to do. So if you have views, then the view, for example, if you have a window that shows the map, and for example, it might appear that it's displayed in real time and change in real time, then as it changes, why is it changing? Because it's actually interrogating. For example, you might have a graph view of your map. So it's essentially this window component is interacting with the model, the map in the model, the class map in the model, and it's interrogating the state of the map. And then depending on what state has been changed, then would actually redisplay the map as it is being changed. Okay. So we'll see later that there's a notification mechanism. Actually, as the map is changing its state, it will notify its view so that the view or the view will then interrogate the map to actually display the new information. So there has to be this communication between the model and the view. That's one of the duties of the model, to provide information to the view. When you have event-driven systems, the model will notify the observers. So that's what we will see that there is when you, that's where the observer and observable components, which is the observer pattern, will take effect or will actually implement this notification mechanism. Okay. So that's what is the role of the observer pattern in this architecture, to actually implement the notification mechanism between the model objects and the view objects. It implements the communication between the components. Okay. So let's proceed further with the view. So what is the view? The view actually renders information that is stored in the model. So it's frequent for people to think, for example, in the game, to think of the map. When you talk to people about the map, then right away they see a graphical representation of a world map. Okay. So the map that you have in the model is not a graphical representation. It is, for example, a graph, which is nodes that are countries that are connected with other nodes. Okay, it's not a graphical representation, it's just a data structure that represents different countries that are connected together. Okay. Then this view can, yes, have a graphical representation, but it would actually interrogate that data structure here to actually show the state which is displayed on a image of the world map. Okay. So what you have here is not this image of the world map. What you have here is a data structure that actually is some kind of abstraction of a world map. That's what is the common misconception, that the objects that are to actually identify with one another, that view and the model is actually the same. It's not the same at all. Another point of view also is that you may have actually different views. So when you may want to represent a map using a certain view, that might be the graphical representation of the map. You might have another view that would be just a text representation of the same map. Okay, a view is just displaying some information, not necessarily even all the information about the map. It's just that a certain view is designed to show a certain perspective on the state of one of the objects that is in the model. So of course, the idea of the view is to enable a user to actually visualize the information in a way that is suitable for the user to actually use this information for its own purpose, information that is actually stored in the model. Okay. It's very common that the user does not actually have to know all the information that is here. So then you would create a view that shows only what the user actually absolutely needs to do their interaction. So yes, multiple views can exist. So you can have different windows, or one window with different panes in the same window that are showing different aspects of different objects that you have in your model. Okay. You don't have necessarily only one view for an entire application. You can have lots of different views. So there are different ways. The point, as I explained earlier, is that as the model actually changes its state, so you might ask yourself, well, this view, for example, let's say I have my view of my map in the game, the Risk or Domination or War Zone game. I might actually have this graphical representation of my map, and then it's basically updated in real time. Then the question becomes, in what direction is this information flowing? Is this the view that asks information from the model constantly, which would be what is called a pull model? Pull model, the view is there and is constantly asking for the new state to the model object. Okay. That would be a pull model. It's pulling the information. The disadvantage of this is that then the view actually needs to have some kind of loop that regularly asks for the new information. It can be quite wasteful if the information is not changing very often, for example. But then you can also have a push model by which, as, for example, your map is changing its state, then it would actually have some kind of notification mechanism that allows it to actually notify the view. Okay. Then the view, when it receives the notification, then it can actually ask, for example, your map, give me your new state, so that it then becomes updated. So this way, it's only updated only when the state has changed. Okay. And that's what we're going to use by using, that's what we're going to do by using the observer design pattern. Then you have the controller. The controller is this one here. What the controller does is that it essentially controls and manages the user interaction. Okay. So this is where sometimes, depending on what technology that you're using, depending on what libraries that you are using, the controller sometimes is somehow embedded with the view. For example, in many cases, when you create a window that enables the user to interact with the window, very often you have what is called a listener that is somehow part of the window. And then this listener enables you, the programmer, to actually listen to the events that are triggered on this window. For example, a mouse click, or it's choosing a menu option, or things like this. So basically, events are happening on this window. They are trapped by the listener. And very often, you could think of the listener as being somehow the controller. So that's where you might have some variations in the implementation of MVC, because different technologies would actually, some of them would separate very clearly with the view and the controller. Some of them would actually somehow integrate more or less the controller inside of the view. Okay. In my example, I will actually create a totally separate controller, totally separate view, and totally separate model. Okay, but of course, mine is very simple and it does not use any such technology. Okay. Graphical user interface technology. So what the controller does, it actually, for example, if the view, for example, can provide the opportunity to the user to, for example, give some information. So, for example, in the view, there might be some fields where the user can enter some information. So you do some banking on the internet, and then you can enter, for example, how much money you want to transfer. So you have fields here. So when you click submit, then the controller gets the event of the submit, then would actually get the information that you put here on the window, and then gather this information here, and then transform this user interaction, this event, and this data that was gathered on the view, and would gather this information and actually send it to a model object to actually enact, for example, your deposit or transfer money interaction. Okay. In this case, it's a banking application. In our case, what we, for example, we're going to have a view, which is the map view. So the user is going to view the map, and then it's going to make a decision as to what action to take. And the user is going to enter a command, and then this command is going to get some information, and this will eventually call a method inside, for example, of your map to transfer armies from country A to B and so on and so forth. Okay. So the controller is essentially there to get information from the user, from the exterior, normally through event, and the user is providing information. In our case, it's going to be commands and command line arguments. And then it's going to translate that into a function call inside of one of the model objects. So the controller is some kind of interpret between the user and the system. Okay. Another thing that the controller can also do is to create other views or remove views and so on. So depending on what the user wants to do or see, then the controller may also create or eliminate views and so on. So how do you create? Because here you have basically a trio here. You need to have at least one model object, at least one view, and at least one controller. You can have as many as necessary, but there has to be at least one, and normally they are connected as a trio. So first of all, which one are you creating first? Of course, the controller is going to call some method in the model object. So that supposes that the model object is created first before the controller. Okay. The view is going to be connected also to a model object. So the model object needs to exist before the view. Eventually, we're going to see later that in using the observer design pattern, that the model object actually registers a view as an observer of the model object. So there's a kind of a attach and detach process. So when the model, which assumes that the model object exists before, then a view object is created, then the view object is attached to the actual model object. So you see that there's an order in which these objects should exist for them to be connected. Now, this is where the connection is not so, how can I say, always the same. The controller, depending on what is the view, for example, the view can be only display some information. And then there's, for example, the user does not interact with the view. The user the only thing that the view would do in this case is show some information to the user, so that the user can, for example, type commands in the console. Okay, that's what my example will be, and that's what when I describe the project using the commands and so on, that's what I assume it is. Okay, that the user does not interact with the view. If you just give something to the user sees that, and then according to what it sees, enters a command. The user does not interact with the view. So all this to say that, yes, there can be a view, model, view, controller object, but the controller does not need to be connected to the view. Of course, if it's a, for example, the banking system I was describing before, where you have fields in your browser that are asking you what is your account number, what is the amount of money you want to transfer, there are fields in there. So the user then needs to interact with the view that is some kind of instrument to gather data. Okay. So depending on what kind of system you implement, depending on the technology that you implement, they could or not necessarily have a connection between the view and the controller. Okay. In the example I will give, there's going to be actually no connection between the view and the controller. So then, see, this is explaining what's going to happen, the loop that is going to happen when the system is actually executing. So once the model is, the view is connected to the model, and then the controller is connected to the model, and possibly the controller is connected to the view, then somehow as you start the system, the model has some state. And then as the state is set, then this view is notified of that the state has been set. So then the view will react by interrogating the model object and then display and then be sent the information about the state of the model object, and then will display this state to the user. And then the user, depending on what they want to do, will actually do some actions. Depending on what they see and what action they want to take, they will do some action. For example, by interacting, clicking on the view, or by entering commands as a result of seeing some information, okay, as to what they want to do right now. Then as the user is doing some actions or entering commands, then these commands would be somehow interpreted by the controller and transform into function calls or method calls inside of some of the model object. Okay. And for example, some parameters can be gathered from the interaction and or entering commands here. And then these parameters are, this command is, and their parameters is transformed into a method call into a certain method here by passing some information here. And then calling this method, inevitably what's going to happen, it's going to change the state of this object. And then again, if the state of this object is changed, then this object is going to then notify the view that the state has changed. And then this object here is going to react by interrogating the state of the object, getting the information and redisplay the new information. That's the loop that's happening when you actually have the MVC connected through the observer pattern. So that's my very, very short introduction to what is the MVC model. So there's, of course, a very strong relationship, inclusion relationship between the MVC model and the observer pattern. So what is the observer pattern? So here I'm using a very specific kind of way of describing patterns. I'll come back to that later when I introduce officially designed patterns. Okay. So first, there's the motivation for the observer pattern, because keep in mind that the observer pattern is not something that is strictly only related to MVC. It's a design pattern that can exist outside of MVC. So what is the intent or the motivation of this design pattern? Essentially, what I've been describing here is that you have a certain object, and then when this state of this object has changed, then you want to be able to notify another object that the state has changed. And then possibly this object here will react by interrogating the state of this object and then update itself. Okay, so that's what in general what is observer and the observer pattern. You have an observable object in the terminology of the observer pattern. This is the observable object, often called the subject. Okay. Each pattern has their own terminology. In the terminology of the observer, this is not a model. This is called a observable or a subject. And this is not a view. This is an observer. Okay. So this is the same concept, but it's not the same terminology. Again, each different design patterns, the architectural design MVC is some kind of pattern. Its terminology is model view controller. The observer pattern, its terminology is observable observer or subject observer. So when you learn design patterns, you have to learn also what is the terminology. It's important not to mix these terms together, because when you discuss with people, if you don't use the right terms, it becomes confusing. So in the observer pattern, you have the observer, which is an object, and what it wants, this object, is to be made aware when the state of another object has changed. And very often what the observer will do is that it will be able to interrogate this other object and then get the state of the other object. Okay. So it's a communication mechanism. Observer is implementing mostly a communication mechanism by making one object to be aware that the state of another object has changed. That's essentially what the only thing that observer is. Okay, so let's see the design diagram describing the observer. So, so the subject is the, might say, very often you would see observer and subject, observable or subject. The official term for the observer pattern is subject. However, you might know that in Java, there used to be default classes or classes in the basic language that were observable and observer. Okay. That's what is creating the confusion here. So the real term in terms of the observer pattern is subject. So in this implementation or design, sorry, about the observer pattern, you have subject class and observer class. Subject and observer, what they do is they provide the implementation for the notification mechanism, as well as the attachment and detachment between the subject and observer. So that when this observable object here, or this subject or this model object comes into existence, if it wants to actually be connected somehow with an observer, then it needs to register or attach this observer to itself so that it will know to which objects, which are the observers, to send notifications that it has actually changed its state. So you could have as many observers as possible that can be connected to one observable object or subject object. And then eventually, okay, so these are the super classes of subject and observer. So whenever you design any kind of observable, then they have to be a superclass, a subclass of subject. And whenever you design any kind of view, there must be a subclass of the observer superclass. These are the superclasses here. And what they do is they implement the communication mechanism between any of the objects that are subclasses of them. So they provide this communication mechanism to all the objects that belong to all the subclasses of these classes. And then these subclasses are called concrete subject and concrete observer, which are all subclasses respectively of observer and subject. And then this is the description of what are each of these subclasses. I already explained that in the previous slide, so I'm not going to repeat that. So how does this work? What's the behavior of this whole thing? So first of all, the client, which is the application that is actually using this subject and observer, they will instantiate the concrete observable object or your model object. Just as I described before, first step is that this model object, in this case it's a concrete observable, is going to be created. Okay. Then it's going to actually register or attach this observer object after it has actually been created. Then forever after this has been attached, after this observer has been attached to this subject here, then anytime the subject is actually changing their state, then they will actually notify any observer that has been connected or attached to it. Okay. Then these observers will be able to interrogate the state of their connected object or subject, and then they'll be able to update their state themselves accordingly, or to do some actions according to what the new state is. What is interesting about this pattern is that if you have already your model objects and implementing your business model for your application, making them actual observable objects requires very little change. Okay. So you can have an application that's already working without using the observer pattern, and then somehow introduce the observer pattern inside of your design without having to change much of what you already have. That's one of the great advantages of the observer pattern. So let's see into, so that there we go here with explaining the actual example that I have, that I've shown you before on the website. So that's the same example that will actually be shown in the lab. So here, my observer, the superclass of observer is the observer superclass is actually in Java, that will be an interface. So what this interface does, it forces any subclass or any view that you will create to actually implement the update method. Okay. The point is that the observable class is going to actually work assuming that there's an update method inside of any of the view or observer objects. Okay. So it's forcing your view object or your observer object to implement the update method. So basically, what is it going to do with the information? How is it going to get the information from that? And what is it going to do with this information? Is it going to display something on a window, on a console, or what is it going to do? It just depends on what this view is actually doing and how it's implemented. But whatever it does with the information is going to be implemented in this update method. Anytime the model or the observable is going to notify, this method update is going to eventually be called. Then you have the observable or subject class. So what this one does, it actually includes the implementation of the attach and detach, which allow it to actually attach itself to certain observers. Okay, so you see that it maintains a list of observers. And what attach does, it actually adds an observer to the list of attached observers. And when you detach a certain observer, it simply removes it from the list. So it maintains a list of views that are attached to this model object. in terms of MVC. I'm going back and forth between MVC and observer here because the entire example is actually more than just observer. It also includes controller. And you have to understand that controller is not part of the observer pattern. It's part of MVC. But my example here, yes, it's an observer example, but also includes controller. And then what it does, it implements a method, for example, named notify observers. And then what it does, this method, when you call it, then it actually loops over all the elements of the list of observers and then calls the update method on each of the connected observers. Okay. So that's where the update method that we were describing here is actually called. So eventually what's going to happen is that any model object, when it actually changes its state, you have to insert in the code there, after it changes state, you have to include a call to the notify observers method, which will then loop over the list of all the observers attached to this model object and then notify them by calling update on the actual view object. Okay. So you see, that's quite simple. So what it does is basically it implements some kind of communication mechanism between the model object and the view object. Then here, this was for the observable and the observer. That's the two superclasses. Their goal is to actually implement this communication mechanism. Okay. Of course, my objects here, they are doing their own business. On top of being able to communicate with one another, this model object is doing its own business, part of the business logic of the application. Okay. So my example here, it's actually a clock. So it's a clock timer. So basically this object here, it maintains hour, minutes, and seconds. And then eventually the user is going to use this clock to count a certain number of seconds. Okay. It's kind of a timer. So it's my clock timer model object or class. It contains hour, minutes, seconds, and the interval that you want to be able to count that many seconds for. And it has a get minute, get hour, get second, and then it has a tick method. So what the tick method does is that depending on what time you are, it's going to add 1 second. Every time you call tick, it adds 1 second. And of course, if you reach 60 seconds, and then it adds a minute and then resets seconds to 0, it basically counts time in terms of hour, minutes, and seconds each time you call tick. Then you see here that as soon as I'm finishing updating the hour, minutes, and seconds after a tick, then I call notify observers. Then I remind you that when I call notify observers, what it does, it will call update on all the views that have been connected to this object. So my view in my case, which I will show later, the only thing it's going to do is going to display the time, the current time on the program console. Okay, so only displaying something on program console, and then the user interacts with the program console. It's not a GUI application. So when notify observer is going to be called, then it's going to basically result in the new time to be displayed on the program console. And every time I'm going to call tick, it's going to increment 1 second, then call notify, and then poof, the new time is going to appear on the program console. So that's how there's a communication between my clock object, my clock timer model object, and the view. And the view basically redisplays itself every time it's notified. Then I have another method to actually set the time, which is setting the original starting time of the clock timer. Okay. When I set the time, I also want to notify the observer, because the state has been changed. Here I put some method here just for the sake of showing that it's possible that sometimes the clock may change its state, but it doesn't want to notify the observer because, for example, the observer is not displaying this information, so it does not need to be notified. So it's possible that the model object does not want for the view to be notified when some changes are applied to it. Okay. So this is my model object in my example. So you see that you must extend observable. So that means that it would then inherit from this here and thus have this notify observer, detach, and attach available to it by inheritance. And then that's why you can actually call notify observers here. Okay, so let's go to the view. So here, this is my digital clock view. So that's my view or observer class here. Okay. So you see that my observer class is actually an interface. So here I must implement the observer interface. Observer interface was defined here. Observer interface is very simple. It basically says I must implement this update method with this parameter here. So my digital clock view is what it does. It has this update method. So whatever is this object I had here, because now it is an observer, it must implement this update method. So you see this method, what it does. Well, inside of the digital clock view, first of all, the update method, it actually receives an object as a parameter. Okay, so very frequently, not necessarily, but the update method, most frequently, it actually is being passed this object itself or a reference of this object. So that when the update method is being called here, that it has actually a reference to this object here, so it can actually interrogate this object and then extract the state that it wants, the information that it wants from this object, and then display this information. So you see that my update method here, as I'm calling notify observers here, I'm passing a reference to the clock timer model object. So that eventually, as notify observer receives this object, or this reference to my object, it's going to pass it to update, so that when update is being called here, then the update method in my view here actually has a reference to the clock model object. So then it can ask to this clock, what is the hour, minute, and second, and then display to the console the current time. Okay. So the clock changes their state. They call notify observers, which calls update here. Then updates receive a reference to this object here, interrogates the object, and redisplays the new information. And every time this happens, the time is actually redisplayed on the console using this code here. So this is nothing, it's not rocket science. You could do this exactly the same thing with something other. That's not saying that's the only way to do it, but this is just a pattern that a lot of programmers know. If you want to have notification mechanism like this, or display information in real time, a lot of people would say, let's use an observer. Okay. It's not to say that's the only way to do it, but it's a very common way that a lot of experienced programmer would actually know that this is a way. And the more people are using this, the more everybody is at ease and understands what it is. If everybody would be doing their own way of having the same mechanism, it's more confusing because there's a lot of different ways you can actually do it. But that's one of the advantages of using design patterns. It's become some kind of standard way of actually approaching certain problems. Then let's introduce here the controller. Remind you that the controller is not part of the observer pattern. Okay, observer pattern was what I described before. Now I'm describing the controller, which is part MVC. Now, what does the controller do? As I explained before, the controller actually manages the user interaction. That's exactly what this code here is doing. What my controller is, it actually contains a clock view and a clock model and is somehow connected to both of them. So when I create a new clock controller, I have to pass it to parameters that are the view and the model, which now become a reference that is maintained inside of the controller. Essentially here, my controller is connected to the model and the view. Okay. If you are, if you have good eyes, you may see that in this case, the controller does not actually use the view or does not call methods or do anything with this view. So just for the form here, I have included the fact that the view is somehow connected in the controller, but in this particular example, there is no interaction between the controller and the view. The only interaction is with the user. The user sees information from the view and then decides to enter commands. There's no interaction in the software between the view and the controller in this particular example. Then what it does, it has a single method called control clock, and it basically prints out a menu to the program console, asking the user, what do you want to do? Do you want to set the time? Do you want to set the time interval of the timer? You want to start the timer or exit the program? So if the user enters 1, then it asks for 3 different integer values. Then once it has these 3 integer values, it will call in the clock model the set time method. So set time is in my clock model here. The clock model has a set time method, and this method is called, and then in the clock, the hour, minute, and second is received and set in the clock. Then notify observers. Then what happens is that the actual so when you call notify observers, then every observer that was attached before is going to be, the update method on these observers is going to be called. Then in this case, it's going to call the update method here. Then the view is going to interrogate the clock that has been passed as a parameter here. And then it's going to interrogate the hour, minute, and second, and then display it on the program console. So user selected 1, then entered, for example, 12:00. So the clock is now set at noon. Then as soon as this is done, then notify observers is called, which calls update here, which is interrogating the clock, then redisplaying the information here. It is now noon. Then if the user enters set time interval, then what's happening here is kind of the same thing. So here the user enters 2 and then enters, for example, 5. So you want to count 5 seconds. So then the user enters 5 here, and then this 5 is passed onto set time interval. Set time interval here sets this value here inside of the data member here, but here notify observer is not called. Okay? So nothing is appearing on the console. Just to show that sometimes the state of the object may be changed, but nothing is redisplayed because notify observer was not called. Then if the user enters 3, then that actually calls start on the clock. Start, I remind you what start does is it calls tick for as many times as the value of time interval. So if the user entered 5 in the preceding step, then it's going to call tick 5 times. Then when it's called tick, then it's going to add 1 second and then notify observer, which is going to then update the time value. Then tick is going to call again. It's going to change the state here. There's going to be notification, call update, redisplay. And tick is called again. Then state is changed. Notify observer, call update. It's going to do that 5 times. Okay. And then every time the time is redisplayed on the console. This is how this example is working. Then the main class, or the class that contains the main function, very simple. So it contains a model, view, and controller object as a main function here, or main method, which creates an object of this kind and then calls this demo function here. What it does, it calls control clock of the controller, which then displays this menu to the user. And then the user does what I just described before. And the user interacts until he enters 4, in which case the program exits. Now here you see that I have detach here. So you might ask yourself, well, how come you call detach, but you never call attach? Keep in mind that when I call actually the constructor of the view, I have actually to pass the clock model to the view, and then in the view here, I actually attach this view to the actual model object. Okay. You don't have to do that if you would not pass the clock model and attach in the constructor, then you would have to call attach here. So that's about it for that. So one of the things that's important to realize is that depending on what is the application, you may have the creation or deletion or connecting different views to objects inside of this of the application. Here, my application is very rigid, and it always creates model, view, controller, all connects them together, and then it executes. In most applications, actually, the views will be dynamically created and deleted and disconnected as the application is running. Remember, you might be clicking somewhere, create this view, and then a new window appears. Some things are shown on the window, and then you close this window, it detaches the view, and so on and so forth. Most applications that are using MVC would be much more dynamic than what my very simple example is showing here. So that's it for this description of the observer pattern and the MVC architecture. Thank you. Bye-bye.